All right, so let's take a look at this problem. The altitude of the triangle is increasing at a rate of 1 centimeter per minute. Okay, so this is about a triangle. So I'm gonna draw a triangle. I don't know what shape is it. How the shape of the triangle look like, but it's just any triangle. And the altitude is the height. So this is the altitude. So altitude is the height. And the problem say the altitude of the triangle is increasing at the rate 1 centimeter per second. So it means they give you what is the rate of change of the height. dx over dt is 1 centimeter over minute. This is the positive because it's say increasing. While the area of the triangle is also increasing at the rate of 3.5, so it means dA over dt also positive 3.5 centimeters square per minute. Okay, now the question is that at what rate is the base of the triangle changing? So it means they want you to find the rate of change of the base. So I call that as a B. Okay, so the rate of change of the base is dB over dt. And they want to know what is the rate of change when the height is 10 and the area given is 88 centimeters square. Okay, so now let's put the equation that relate all these three variables, which is the area of the triangle, right? So we have the formula is the area of the triangle is 1/2 base times height. So all of this is just for setup. And then after this, we're gonna take the derivative on both sides. So derivative on the left side is dA over dt. And the derivative on the right side is the product rule. So we're gonna have F and G. Okay, so when your F is 1/2 B, your F prime will be 1/2. The derivative of 1/2 B is 1/2. And then we're gonna have the chain rule of B, which is dB over dt. It's just same as the implicit differential equation. When you take the derivative of y, you're gonna have f prime equal 1/2 times b prime. So it's the same thing. B prime is dB over dt. Okay, and then we have g is h. So derivative of h is 1, and then the chain rule. So you're gonna have dx dt. So f prime g, which is 1/2 dB dt times g plus g prime f, so it's gonna be 1 dx dt times f, which is 1/2 b. And when we're done taking the derivative, we will start plotting all the information that we have above here. So we have dA over dt is 3.5, and then equal 1/2. dB equal, over dt is what we are looking for, so we keep it there. And then h is at 10 plus dx dt is 1 times 1/2 b. Look like we don't have b. So how do we find b? We're gonna use the height and the area because we haven't used this yet, right? So we know area is 1/2 base times height. When area is a constant 88 and the height is 10, what is the b? The height is 10, then the b gonna be 88 equal 5b. So b will be 88 over 5. And then we put in the calculator, 88 over 5 will be 17.6. So B is 17.6. So we put that in here, which is 17.6. And then we simplify everything and isolate for dB over dt. So 3.5 equal 5. This one is 10 times 1/2 is 5 dB over dt plus 8. And then we solve for dB by subtracting 8.8 on both sides. So we have 3.5 minus 8.8 and then divide 5. So we will have negative 1.06 centimeter per minute. Okay, so you subtract 88 and then divide 5, you will got negative 1.06 centimeter per minute. So it means the base of the triangle is decreasing at the rate of 1.06 centimeter per minute. Okay, how do we know this is decreasing? Because the negative telling us that the rate is decreased.